Prove that gamma of z plus 1 is equal to z gamma of z. Welcome back to my second video on gamma functions. Okay, and today's video we are going to prove by infinite limit definition that gamma of z plus 1 is equal to z gamma of z. So first we start with the definition of gamma. So you say gamma of z is equal to limit as n approaches infinity of the product of 1, 2, 3 all the way up to n over z plus 1, z plus 2, z plus 3 up to z plus n. This multiplied by n to the power z. So this is the definition for gamma of z. Okay, but what we have is gamma of z plus 1. So what we can do, we are going to let z to be z plus 1. That is step 1. So you say let z equal to z plus 1. So where there is z, we are going to put z plus 1. Okay, so we are going to have gamma of z plus 1 is equal to limit as n approaches infinity of the product of 1 to 2 to 3 up to n over where there is z, we put z plus 1. So we have z plus 1, z plus 2, z plus 3. This will be up to z plus n, then multiplied by z plus 1 plus n. This multiplied by n to the power, where the z is z plus 1, so n to the power z plus 1. Okay, so that is gamma of z plus 1. Okay, we can see that from this equation we have z here in front. So to create z in front here, we can multiply z to both the numerator and the denominator. And we know that if we have same value as numerator and denominator, it means those two values can cancel out, meaning nothing has changed. So second step, multiply z to both the numerator and denominator. Okay, so we are going to have gamma of z plus 1 is equal to, so we have z to the numerator, that is limit as n approaches infinity of the product of 1, 2, 3 all the way up to n over, so we have z to the denominator, then we have z plus 1, then z plus 2 all the way up to z plus 1 and z plus n and z plus 1 plus n. This multiplied by n to the power z plus 1. Okay, so what we can do next, so here what we can do next is separating the expressions to come up with gamma of z, this one, to come up with this. this thing. Okay, so you can say gamma of z plus 1 is equal to, we have z here, limit as n approaches infinity of the product of, so we are going to separate this. We remove this. We are going to remove z, this over z plus 1 plus n, because this is not part of our definition, so we remove this. Okay, we are going to have two products in short. So we are going to have the product of 1 to 2 to 3 all the way up to n over, so we have z plus 1, z plus 2 up to z plus n. N to the power z plus 1, this can be written as, we have n to the power z plus 1. This is the same as n to the power z multiplied by n, because if you multiply numbers with same bases, you add the powers, so it will be n to the power z plus 1. Okay, because the power here is 1. So where there is z, n to the power z plus 1, we are going to have n to the power z multiplied by n. Okay, so here we get n to the power z. This multiplied by, so here on top we have remained with n, so we are going to have n over z plus 1 plus n. Okay, and we know that this one here, limit as n approaches infinite of 1 with the product of 1, 2, 3 up to n over z plus 1, z plus 2 up to z plus n to the power n to the power z. This is the gamma of z. Okay, so we are going to have gamma of z plus 1 is equal to, so we have z, so this is gamma of z, so this is gamma of z, so this will be limit as n approaches infinity of n over z plus 1 plus n. Okay, so we have gamma of z plus 1 is equal to z gamma of z limit as n approaches infinity of n over z plus 1 plus n. Okay, so what we can do here, we can try to get rid of this n. Okay, so we are going to divide n through the expression. Okay, so we are going to have gamma of z plus 1 is equal to z gamma of z, then we have limit as n approaches infinity of, so we say n divided by n, you get 1 over, this will be z over n plus, this will be 1 over n, n divided by n is just 1, so plus 1. Okay, so we can divide out the n here on the denominator, so we are going to have gamma of z plus 1 is equal to z gamma of z limit as n approaches infinity of 1 over, we divide out z here, we are going to have z, then 1 over n plus 1 over n plus plus 1. And we know that limit as n approaches infinity of 1 over n, this is just equal to 0. Okay, so here limit as n approaches infinity of this expression, we know that 1 over n will approach 0. So we are going to have, where there is 1 over n to be a 0, and here it will be a 0. So it will be 0 plus 0, that is 0, plus 1, that is 1. So this whole thing, limit as n approaches infinity of 1 over z multiplied by 1 over n plus 1 over n plus 1, this whole thing will give us a 1, because we are going to have 1 over, this is 0, so 0 plus, this is also 0, then plus 1, then 1 over 1 is just 1. So gamma of z plus 1 is equal to z, gamma of z, this is 1, so multiply by 1. And we know that any number multiplied by 1, you get that number. So gamma of z plus 1 is equal to z gamma of z. Hence proved. Okay, so we have proved by infinite definition that gamma of z plus 1 is equal to z gamma of z. Thank you so much for your time.